the data set given to you. But for the ungrouped data, this is quite different. For the ungrouped data, take for instance, you have your x, or you have your x. I want to do something here. Before you even have your x, let's have this example. Example 1. The following scores, or the following values, are the scores of statistics students in an examination, in an exam. You know, for every exams, we have some outliers. What do I mean by outliers? You have some people getting, in the exam, maybe over 100, you have some student getting 30, student getting 100. In fact, if you have some bonus points, you see student getting the bonus point. And have you ever seen a situation where you have student getting 5 out of 100? I have seen that several times. Yeah, so those are the outliers, but don't worry, that's another aspect of statistics. Now, the following values are the scores of statistics students in an exam. Now, you have 86, you have 55, you have 91, you have 68, you have 67, you have 53, you have 78, you have 86, you have 77, you have 92, you have 61, you have 59, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, you have 80, you have, well, let's say 86, you have 52, you have 95. How many values do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Fine. The A, the mean, B, the median, C, the mode. How do we do this?
Yeah, okay. Mean, just add them all together and divide them by the number.
Now, here we want to use the ungrouped data. Actually, 15 values are still pretty much easy and very small.
Mm-hmm.
Sometimes you can have like 40 values. Yeah. Sometimes you can have like 50, 60 values. So, but for this is pretty much easy. Now, to do this, there's something we call the class width. In this case, I want us to use the class width of, let's say, 10. Class width is, when we talk about the width, the intervals we want to use. If you are using 1 to 4 or 1 to 5, you can use 6 to 10. Okay? But now I want us to use class width of 10. Now, there are several ways for choosing your class intervals, for choosing your class size, and some other things, but I just want to be minimal here. Now, this is the score. What is the minimum value we have?
52.
52. Okay, so if you are choosing the class width, we can start from 51. 51 to what? 60. I think that is 10 values, right?
Mm-hmm.
Yes. Because if it is 50 to 60, that is 11 values. 51 to 60 is 10. So the next one is going to be what? 61 to 70. The next one is going to be 71 to 80. The next one is going to be 81 to 90. And the last one is going to be 91 to 100.
So you're going to try to find out the average of all of those digits and then just multiply them by the amount of them they are?
Not now. Not that. Not that. Not that. So this is what I want to do. For this, the next is frequency. Don't worry, I understand what he's trying to say. Next is the frequency. Or, the frequency. Or let me say X. You can find your X, you can find your F. X is the values. So what we need the mid values, which is going to be the average of these two. So what's going to be this value of X?
55 plus 53.
51 plus 60 over 2.
Oh, so 55.5.
Yeah, 55.5. Okay. 61 to 70, you have what?
65.5.
65.5.
75.5.
75.5.
85.5.
85.5.
And 95.5.
And 95.5. Now, the frequency is this. We want to see how many values fall within the range of 51 to 60. So you come back here, we check. From 51 to 60, how many values do we have? Let's start. 1, right? 2, 3, and 4. So the frequency is 4. So we have 4 values falling in the range of 51 to 60. Now, next is 61 to 70. 61 to 70, 1, 2, 3. Yes, we have 3. We have 71 to 80. From 71 to 80,
2.
1, 2. Yeah, just 2. 81 to 90, we have 1,
2.
2,
3.
3. Yeah. And 91 to 100, we have 1,
3.
2, 3. Now, how are you going to be sure if what you've done is right or wrong?
If the total is 15.
Perfect. Yeah, that's great. If you add this up, it's going to be 15. That's it. Now, the mean. What is the formula for calculating the mean?
Adding all the numbers and then dividing them by the amount of numbers.
Now, this is not going to be different. Yes. Yeah, you can say adding all the numbers and dividing is going to make sense. But now, you are having frequency. You are having what?
Frequency.
Anytime you are having frequency, even if it is the other one we did, anytime you are having frequency, the case is going to be different. Okay? Now we're going to be using summation f of x over summation f. For example, in the other case, if you have 1, 1, 2, 2, 2, 3. If you want to find the mean, you can say, oh, this is my x. 1, 2, 3. 1 appeared how many times? 2 times. 2 appeared how many times? 3 times. And 3 appeared how many times? Just 1. Okay? So you use summation f of x. So here too you can use the same thing.
Would it not be exact though? Would it not be exact though?
Exact what?
Exact like values.
Exact values. Yeah, it's going to be the same.
Now he's saying if we added them normally, okay, added all the 15 numbers and then divided them by 15,
Let's do
it's
that.
not going to be the same.
Let's try it.
Okay, let's try it after we finish this,
Let's try. Yeah, it should be very close.
It's gonna be close, yeah.
Yeah, very close, approximate value. Very close. We do it. We tried it. So what is your f of x?
So just adding 55 multiplied by 4, 65.
And I don't want to get large values. I'm having problem with that. I don't want to get large values.
You could subtract all of them by 50 and then add 50 to the total.
I understand, but I mean, I should have used smaller values. Something you can just do without using calculator. You know, here you are having times 5. Okay, this is going to be what?
222.
Because this is like having 56 twice. No, 56. Yeah, this is like having 50, 50, 55, 55, 55, which is 220, and you're having plus 2.
In this situation, you can just do 5.5 multiplied by 15.
Yeah.
Because they all have 5.
What about this? 65.5 times 3.
18.
In fact, let's talk about the mode and the median for this. Not to waste our time, because time is running. Don't worry about the mean. I'm going to give another example on the mean. Let's talk about the median and the mode. I mean, the mean is pretty much easy. Let's talk about the median. Let's talk about the median and the mode. First, let's talk about the mode. You see, here, to get the mode is difficult. To get the mode can be difficult.
Yeah, with like the axis here.
So the modal class. Here, to get the modal class can be difficult. The modal class, what I mean by the modal class is that, in fact, sometimes you will not be provided with this. You don't have this. You only have this information. You don't even have this at all.
Huh.
You only have this. Now, to get the modal class, that is the first thing you have to do. Assume you don't have this. If you have this, it can be easy for you to say, oh, which value appear more than once? You can easily detect. Assuming you don't have this, let me clean this. Let's assume you don't have this, so that you will not be confused. This is all what you have. This is the information you have. This is all what you've got. Now, what is the modal class? That is the first thing.
55.5.
55. This is the modal, not 55. This is the modal class. This is the modal class, but not the mode. Yes, modal class means your mode is going to be from 51 to 60. That's what the mode is saying. It's going to be from 51 to 60. Okay? And we have the formula for calculating the mode. The mode is going to be, I hope I remember, it's been a long time, LB plus or minus, I think it's should be, is plus F1 over F1 plus F2. Is it plus or minus? I know this should be the formula. Let me see if I can remember. Plus or minus mode formula. LB plus or minus, okay. Let me see if I can, I think, how can I easily see it here? I'm not prepared for this. Let me see. Can you hear me check? Let me quickly check my channel. Let me check.
Check this out.
The mode. should be, I think should be plus or minus. So your F1 is going to be the frequency of the modal class minus the frequency before mean and median. This is mean and median of ungroup data. Ungroup data mode.
For groups
Okay,
or
group.
group data?
Yeah.
Groups.
I think I've seen an example here that I did. For group data, I forgot to mention that. Is it plus or minus?
Fine. Is it?
No.
I think it's this one, right? This? Yeah, is it this one? I don't know about mod I minus.
I can't see. Okay. Do I?
This.
Yeah, I see them using. I think I've seen what I want. Yeah, it's plus. I've seen what I want.
See?
Yeah, it's plus. I'm going to break it down. So it's plus. So times C. Now what is F1? F1 is the frequency. The formula you showed me, this is how they derived it. But this is the shortened form. Is the frequency of the modal class minus the frequency before it. F2 is going to be the frequency of the modal class minus the frequency after the modal class. Okay? F1 is the frequency of the modal class minus the frequency before the modal class. I mean, except you are using this thing, I'm not sure if you are not going to forget later on. But I mean, it's just you're going to remember that, oh, somebody taught you this. Yeah. But when you get to college, probably they won't teach you this. What you just need is to use your calculator TI-84. Once you know how to use TI-84, everything is solved. You don't need to use all this formula again. So F2 is frequency of the modal class minus the frequency after the modal class. Now, looking at this is the modal class, right? So our LB is the lower boundary of the modal class. Lower boundary of the modal class. So take note of this somewhere. Let me write it in. F1 is the frequency of the modal class minus the frequency before. And your F2 is the frequency of your modal class minus the frequency after it. Now, next you have to get your boundaries. So the boundaries here is lower boundary. Lower boundary for this means you have to take 0.5 away from this, add 0.5 to this. So the lower boundary of this is going to be 50.5 to 60.5. So the upper boundary of this is going to be the next lower boundary. So this is going to be 60.5 to 70.5. Next, this is going to be 70.5 to 80.5. And I'm feeling guilty for teaching you this.
Yeah,
You shouldn't have gone this far. I was like, I shouldn't have gone this far. Okay, let's continue, don't worry. 80.5, because things is changing right now. I mean, people don't usually do long mathematics again. Yeah, people don't stress themselves, just plug in the values, your calculator is going to give you the answer. That's it. Now, the lower boundary of the modal class is what? This is the lower boundary, which is going to be 50.5 plus F1, which is the frequency of the modal class, which is what? 4. Do you have any frequency before it?
No.
No. So this should be 4. So F1 is going to be 4 plus frequency of the modal class and the minus frequency after. What is going to be F2?
1.
1, right? Times C, which is the class width. The difference between this is what?
10.
So your mode is going to be, why are we looking for the mode? When we know that the modal class is 51 to 60, we want to know the exact value of the mode. The exact value of the mode. But the mode is going to be between these two values. It can be 52, 53, 54, 55, 56, 59. So we want to know the exact value. So here we have 50.5 plus, this is going to be 4 over 5 times 10. 5 here 1, 5 here 2. 2 times 4 is going to be what? 8. So the mode should be what? 58.5. Approximately 59.
How can we be sure that that actually is the mode? Because that could be something that's not even in the actual numbers.
Actual numbers?
Like if we have the data before, 58.5 was not there.
Yeah, approximately you use 59.
59 was there.
Only one.
But most cases, I just think about this question, but in most cases like this, if you are using the group data, we always have like large numbers of values. That is what prompted us to use the group data. I'm just giving you a very short data set. Sometimes you can have up to like 60, 100, a large values of in numbers. So for you to identify, it can be a little bit disturbing. So we resort to using these group data. You just partition. Some text you can use 5, some you can use 10, some you can even use 20. Okay? But yeah, even for the mode is pretty much easy. When you want to talk about the median is a little bit more complicated, because for you to use the median, I will have to teach you what is called cumulative frequency again. So anytime you hear the word cumulative frequency is just adding up the frequencies together. Cumulative frequency means, if I want to choose cumulative frequency for the median, you're going to start with 4. Then 4 plus 3, which is 7. 7 plus 2, which is 9. 9 plus 3, which is what? 12. 12 plus 3, which is what? 15. So we use the cumulative frequency for the median, to calculate the median. First, you get the median class. Then use this to calculate the median. Don't let's go far about this. Let me just teach you, what is the time? 6. I'm just going to teach you relative frequency for today.
Okay.
That one is very important and it's very simple. Relative frequency. Should have take the picture, please. I should have just teach you simple statistics. Actually, this to me, in Nigeria, we call this high school statistics.
Really?
Yeah. You have to do this in your qualifying examination. You have to.
Never done this.
You have to. If I in SS2, no, SS3.
I didn't do it because of the translation from Saudi.
Possibly here, even in college, we don't do this.
Really?
Yeah. What I'm teaching, I will just teach you how to use calculator to do this. The only thing I teach is just group data, like the one we did yesterday. That's the only thing we do. Now, let's talk about relative frequency. This is very important too. Now, for relative frequency, you have the following data sets. Calculate the relative frequency for the data below. Here we have 1, we have 5, we have 2, we have 3, we have 1, we have 2, we have 4, we have 1, we have 5, we have 2, we have 3, we have 2. Here we have 2, we have 5, and we have 3. So these are the informations you have. Okay? Now, to calculate the relative frequency, you have the value of your x. What are the values of x? Distinct value of x. 1, 2, 3, 4, 5. We have the frequency. Frequency means the number of occurrence. How many times do you have the x values showing up? So how many 1 do we have there? 1, 2, 3. Do you know what I used to do? Although there's something we call the tally. When you cancel 1, you put tally. When you cancel 2, 3, 4. When it becomes 5, you do like this.
Yeah.
Just to avoid mistakes. Now 2. How many times do we have 2? 1, 2, 3, 4, 5, 5. What about 3? 1, 2, 3. What about 4? 1. What about 5? 1, 2, 3. Now this, assuming I just want to ask you for the mean here, I think this one is easy. Even if you want to calculate the mean, f of x. If you use that formula for this, I think we can do that. Let's calculate the relative frequency, then we can calculate the mean, median, mode from this. It's pretty much fast. This is not group data. It's still on group data. Now, the relative frequency, I'm going to use RF. Relative frequency. To use the relative frequency, what is the sum of the frequencies first? 3 plus 5?
7,
8 plus 3, 11, 12, 15, right? Relative frequency is very simple. Just pick the frequency of the class, which is 3, divided by total. Relative frequency are usually in percentage. 3 over 5 is what? That is 1 over 3 over 15 is 1 over 5, right? And 1 is 1 over 5, I think 0.2.
Yeah, 0.2.
0.2, right?
Yeah.
So in percentage is what? 20%. If I'm right, please let me know. This is 5 over 15. What is the value? This is 1 over 3, which is 33.3%. Approximately 33%, right? I'm thinking this is still the same, 3 over 15, which is approximately 20%. 1 over 15. What percentage of this?
6%.
Are you sure?
No, it's 0.6 repeating percent. So
So-
6%, 0.66666.
So this is going to be 6% or 7% approximately.
Yeah, 7%.
You could say 7% because
Approximate- If it's
6.6 rounded up is 7.
7, yeah. So here we have the same thing, which is what?
20. That's the first one.
Everything must be 100, else you are wrong. So 20 plus 20, 40. This plus this is 40. Plus this is 100. So relative frequency must be equivalent to 100%. So this is just relative frequency. Simple, right?
Yeah.
And in the test, when I give this out, I think I give like maybe 10 points or 15 points for this. As simple as it is. Relative frequency is pretty easy. Okay, if I ask you to calculate the mean is summation f of x over summation f. Okay? Don't get tired.
He started.
Okay, let me put my f of x here.
This thing,
Let me put my f of x here. 1 times 3, 2 times 5,
10,
3 times 3,
9,
4 times
4,
1, 15. What is the sum? This is 19, 29, 32,
41.
41, which is 41 over summation f, which is 15. So what is the value of this?
2.7333.
2.73. If you add this up to everything like this, it's going to give you 41. If you try to.
Yeah.
So what about the median? What about the mode?
Mode
2.
is easy. Mode is 2.
Mode is 2.
And the median is also 2.
How? How do you get a median to be
So
2?
you remove 5 and 1 because they're the same value. And then 3 plus 1, that's 4, and then 5 is more. So it's 5.
You said I'm going to remove what? 5
3,
and 1?
5 and 1, yeah, because they're both 3. They cancel each other out.
So
5 and 1.
Okay.
5 and 1.
Yeah, because they're both 3.
Okay,
they have
okay,
three each,
okay,
and then cancel out, and then 4 and 5, 5 is more. So two.
Yeah, you're right. I mean, everything is 15, right? What is half of 15? 7.5. So you want to see which values are 7.5. 3 plus 5 is what? 8. So 7.5 is inside this.
Mm-hmm.
That's how to get it. Let me explain again.
No.
The frequency is 15, right?
Mm-hmm.
The median is going to be the middle value, which is 7.5. So if you do this, you start adding from the top. 3 plus 5 is 8. 7.5 is inside 8. So the median is 2
Mm-hmm.
faculties. So if you have any values on group data involving frequency, you can do this. Relative frequency is done too. Take the picture. So the only advanced way you can think of is, okay, what about the range? Do you know range?
Yeah, there's the lowest and highest.
Highest minus the lowest. So in this case, what's going to be the range?
4.
4. Yeah, good. Then another problem. What if you want to calculate mean deviation? What if you want to calculate standard deviation? What if you want to calculate the variance? What if you want to calculate the quartiles? The interquartile, the upper quartile, the lower quartile, the semi-interquartile.
It's still gonna be the same thing. For like standard deviation, you're gonna write 3 multiplied by the 1 squared.
Yeah, we're not doing that today. I'm getting tired.
So like 3 plus 1 squared, 5 multiplied by 2 squared, 3 multiplied by 3 squared, 1 multiplied by 4 squared.
No, not multiply squared.
Or add 3 multiplied by 3. I mean 3 multiplied by 1 squared plus 5 multiplied by 2 squared.
You're saying f times x squared, right?
Yeah.
It should be f times x I minus x bar. It's going to be 3 multiplied by 1 minus 2.7 squared. 5 multiplied by, in parentheses, 2 minus 2.7 all squared. The same thing down. You will now find the sum. So the formula for standard deviation is summation f into bracket xi minus x bar all squared. You can do that tomorrow for this kind of example. You can keep this example, take the picture.
Right.
So we're going to use this example to calculate the standard deviation and the variance. Inshallah. But all the same, everything is pretty much easy now. Very easy. How? Just plug in these values in your calculator. Your calculator is going to show you everything in less than a minute. And that's it. See you tomorrow.
Thank you.
Just-
Thank you.